Hey guys, this is Mr. Beckstrom, and today I want to take a look at an example from Section 3.8. This is on implicit differentiation. It's a request I had from example from number 12. This is a pretty good problem. It's pretty lengthy, and we definitely have to stay very well organized when we do this problem. So it's asking us to find the second derivative of y with respect to x of this function here. 21x squared plus y squared is equal to 2. So let's jump right on into this here. So the first thing that we notice is that it's not real easy to solve for y, because it looks like this thing is going to be some type of oval or ellipse, so it's not even a function. So if we were to solve it, we'd have to solve it in two different parts. So it's just better to do this with implicit differentiation. So when we do that, we just go through, we do each term separately, and whenever we differentiate a y variable, we also leave, you can either leave dy over dx, or I just like to leave a y prime, which means the same thing. So I'm going to go through here. So I'm going to do the first derivative. So using the power rule for 21x squared, so that's just going to be 42x plus using the power rule for for y squared is going to be 2y, but I just took the derivative of a y, so I have to also put a y prime. Remember, that's the same thing as dy over dx, and then equals, and then the derivative of a constant is just a 0 there. So I get it like that, not too bad. And then I want to solve for y prime here. Alright, so then what we're going to do is solve for the y prime there. So subtract the 42x from both sides, and then divide by the 2y. So you should get y prime is equal to, make that a little clearer, is equal to negative 42x all over 2y, and we can simplify that. So that's equal to negative 21x over y. So that's our first derivative. But we want to find the second derivative of that. So it looks like we have a quotient rule now. So we're going to do that for the second rule. So the derivative of the quotient is, remember, it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So let's go ahead and do that. So it's going to be of this one right here. So it's going to be so y double prime, that's the same thing as d double prime of y over, right? That's kind of like double prime there. Alright. So we can go ahead and, so that is the bottom times the derivative of the top. So the derivative of negative 21x is just going to be negative 21 minus, make sure I distribute, the top, so that's negative 21x times the derivative of the bottom. The derivative of y is just 1, but we just took the derivative of a y, so I also have to multiply that by y prime, so just y prime there, all over bottom squared here. So the bottom squared would just be y squared. Alright, so let's clean this up a little bit here. So I'm going to get negative 21y, and then I'm going to get a, so that's going to be plus, it looks like 21xy prime plus 21x times y prime, x times y prime, all over y squared. Alright, now we can still do quite a bit with this. We don't want to leave it like this. We want to simplify this as much as possible and leave this just in terms of y's here. So what we can do is this y prime, we know that that's equal to negative 21x over y. So let's go ahead and substitute that in. So negative 21y plus 21x times y prime is negative 21x over y. So negative 21x over y, and then all over y squared. So let's clean this up a little bit. So negative 21y, negative 21y, and that's going to become a minus, and 21 times 21 is 441. So this will be 441. That's going to be x squared over y when we multiply that times that. And this is all going to be over y squared. And then I can multiply both the top and the bottom by a y to get rid of this fraction here. So that's going to be negative 21y squared, because I have to multiply both of those terms by a y. If I'm multiplying the top by a y, minus 441x squared, all over y cubed. And just remember what I did here. So I just multiplied the top and the bottom by a y, right? And that's, I got this. That way I got rid of this fraction here. Now I can pull out a negative 21 from the top here. So negative 21 comes out at the top, and I'm going to end up getting a y squared plus a 21x squared. Yeah, see how fun of a problem this is? All over y cubed. But take a look at this. What is y squared plus 21x squared? We actually know what that is. That's equal to 2, right? Y squared plus 21x squared is equal to 2. So we can substitute this whole thing for 2. So this is equal to negative 21 times 2 all over y cubed. So this whole thing is just equal to negative 42 all over y cubed. And that, folks, is as far as we can go. So, you know, we try not to leave this in terms of more than one variable if we can help it. You know, and we try to kind of leave it as clean as we can. Sometimes, you know, we get stuck, you know, leaving it in certain ways, but a lot of times when we have functions that look like this, we can make substitutions and kind of clean it up and leave it in a nice orderly fashion like this. So this is the second derivative of this function right there. All right. If you have any questions, let me know, and I hope you have a great rest of your week. Thanks.